In the following video, we will start with Pythagoras in the year 530 BC, a time when numbers weren't just math, they were magic, they were religion, and they were deadly. The craziest story about Pythagoras and the secret math cult. You look at a right-angled triangle on a piece of paper. It is simple. It is neat, precise, and completely logical. You probably learned about it in middle school geometry. You plug in the numbers, you solve for x, and you move on with your day. But for thousands of years, this simple concept didn't exist in such a harmless way. To protect the secrets hidden inside that shape, a secret cult in ancient Greece had to risk everything. They built a religion. They hoarded knowledge. And eventually, they committed murder. Why? Because for them, numbers were not just tools to measure grain or count coins. They believed numbers were the literal fabric of reality. Numbers were gods. And inside that very triangle, they discovered a number so terrifying it threatened to destroy their entire universe. It is the 6th century BC. You are standing in the sun-drenched streets of Croton, a bustling Greek colony in southern Italy. You are not a regular citizen. You are an initiate. You wear pure white robes. You have given up all your worldly possessions. You do not eat meat. They have rules for everything in your life. You cannot stir a fire with an iron tool. You must put your right shoe on before your left. You cannot look into a mirror beside a light. And strangely, you are strictly forbidden from eating or even touching fava beans, because they believe beans contain the souls of the dead. It sounds absurd to your modern mind, but to them, these rituals maintain the delicate mathematical harmony of your soul. You have even taken a vow of absolute silence for 5 long years just to prove your loyalty. You are a Pythagorean. The man leading this brotherhood is Pythagoras of Samos. Today, your modern world knows him as the father of the Pythagorean theorem. A squared plus b squared equals c squared. It is plastered in every math textbook on earth. But in his own time, Pythagoras was not just a mild-mannered mathematician. He was a mystic. He was a charismatic cult leader. People whispered that he had a golden thigh, that he could talk to animals, and that he remembered his past lives. Pythagoras taught his followers a philosophy called all is number. He believed that the universe was perfectly ordered. Everything, from the turning of the seasons to the harmony of music, could be explained by neat whole numbers and simple fractions. According to ancient texts, Pythagoras discovered this while walking past a blacksmith shop. He heard the hammers hitting the anvils. He realized that the anvils producing pleasing, harmonious sounds had weights that were simple ratios of each other. 2 to 1, 3 to 2, 4 to 3. This was a profound revelation. It meant that the physical world and human senses were governed by strict mathematical rules. If music was just math, then maybe the orbits of the planets were math. They called this the music of the spheres. They believed that the planets physically hummed as they moved through space, creating a cosmic symphony based on perfect fractions. This was their absolute truth. This was the foundation of their religion. They even prayed to a shape called the tetractys, a triangular figure consisting of 10 points arranged in 4 rows. It represented the absolute perfection of the universe. In this world, everything was rational. Everything made sense. A rational number is simply any number that can be written as a fraction of 2 whole numbers. 1/2, 3/4, 5/8. The Pythagoreans believed that if you zoomed in close enough on reality, everything would eventually break down into these perfect, countable units. There was no chaos. There was no infinity. There were only clean, beautiful, rational numbers. But math has a funny way of revealing truths we aren't ready for. One of your fellow brothers in the cult was a man named Hippasus of Metapondum. Hippasus was brilliant, perhaps too brilliant for his own good. He started playing with the very geometry that his master, Pythagoras, had perfected. Hippasus drew a simple square in the sand. He gave each side of the square a length of exactly 1 unit. Then, he drew a diagonal line cutting the square in half, creating a right-angled triangle. He wanted to find the exact length of that diagonal line. He applied the Pythagorean theorem. 1 squared plus 1 squared equals the diagonal squared. 1 plus 1 is 2. So, the diagonal must be a number that, when multiplied by itself, equals exactly 2. In other words, the square root of 2. Hippasus tried to find a perfect fraction that would equal the square root of 2. He tried 7 divided by 5. That's 1.4. Close, but squared it as 1.96. Not exactly 2. He tried 17 divided by 12. That's 1.416. Squared, it is 2.006. Closer, but still not perfect. Hippasus kept calculating. He tried larger and larger numbers. He covered the sand with fractions. He worked late into the night. And then the horrifying truth dawned on him. No matter how long he calculated, he would never find the answer. He realized that the square root of 2 could not be written as a fraction of 2 whole numbers. It was impossible. The decimal numbers would go on forever, without ever settling into a repeating pattern. 1.41421356, and on into infinity. It was irrational to your modern mind. An irrational number is just another button on a calculator. But to Hippasus and the Pythagoreans, this was a philosophical apocalypse. If a simple diagonal line across a simple square could not be measured by rational numbers, then the universe was not perfect. The cosmic symphony had a screeching, discordant note. The core belief of the Pythagorean religion, that all is number, meaning all is whole, countable, and perfect, was a lie. Hippasus had uncovered a literal glitch in reality. The cult was terrified. If the secret got out, their entire worldview would collapse. The divine order they preached would be proven false. They swore Hippasus to absolute secrecy. The existence of the irrational number was to become the cult's darkest, most guarded secret. It was called the unutterable. But Hippasus could not keep quiet. He was a true mathematician. He believed that the truth, no matter how ugly or chaotic, belonged to the world. He broke his vow. He began to whisper the secret to people outside the brotherhood. He showed them the geometric proof. He exposed a flaw in their perfect universe. What happened next is one of the darkest legends in the history of mathematics. The ancient historian Pappus of Alexandria wrote about the fate of the man who revealed the irrational. According to the legend, the Pythagoreans were so enraged, so deeply terrified by this mathematical heresy, that they decided Hippasus had to be silenced forever. They took Hippasus out on a small boat into the deep, churning waters of the Mediterranean Sea. They tied heavy weights to his body. They looked at their brother, the man who had simply told the truth about a triangle, and they threw him overboard. Hippasus drowned in the dark water. He was murdered, and he was murdered because he proved a mathematical theorem to ensure his erasure from history. The cult even erected a tombstone for him while he was technically still alive on the boat, symbolizing that he was dead to their brotherhood before he ever hit the water. Did it work? Did the murder save their perfect, rational religion? For a time, maybe, but you cannot drown the truth. The discovery of irrational numbers eventually leaked out to the wider world. It triggered the first great crisis in the history of mathematics. Greek mathematicians had to completely rebuild their understanding of geometry from the ground up. They realized that you could not just rely on numbers and simple arithmetic. You had to use visual geometry, unbroken lines, and continuous curves to prove things, because numbers themselves were wild and untamable. This dramatic shift is exactly why Euclid's famous book, The Elements, written centuries later, is filled with geometric proofs rather than algebraic equations. Euclid dedicated entire sections to dealing with incommensurable magnitudes, their term for the irrational. Euclid knew that he couldn't just brush the square root of 2 under the rug. He had to build a system of mathematics robust enough to handle the infinite and the unmeasurable. Because of Hippasus's sacrifice, mathematics stopped being a rigid, dogmatic religion and started becoming a rigorous, logical science. The ghost of Hippasus forced mathematics to evolve. The Pythagoreans eventually faded into history, their cult scattered, and their strict rules about beans and mirrors forgotten. But the mathematical monster they tried to hide, the irrational, became a cornerstone of human progress. Look around your modern world. Today, you use irrational numbers constantly, even if you don't realize it. When you use GPS to navigate through a strange city, the satellites orbiting above your head are using equations filled with pi and square roots to pinpoint your exact location on a curved Earth. When an architect designs a stable skyscraper, they rely on the irrational to calculate stress and tension. Think about the algorithms running the stock market, predicting the weather, or even rendering the graphics in your favorite video games. None of that is possible with just simple fractions. Quantum mechanics, the science that powers the microchips in your cell phone, heavily relies on complex equations and irrational probabilities. When you send a secure, encrypted message on your phone, you're relying on complex mathematical chaos that the Pythagoreans would have murdered to keep hidden. The very chaos they tried to drown in the Mediterranean is exactly what makes your reality function today. The universe is not a simple, neat fraction. It is infinitely complex. It is messy. It is profoundly irrational. And that brings us back to where we started. You look at that right-angled triangle on a piece of paper. It is simple. It is neat. But knowing the dark history, knowing the blood that was spilled over geometry, you realize one profound truth. It is not completely rational.